Ladies and gents, real quick. So, I'm going over last night's homework, which was from page, I think it was 95, 96 in your book, or in the textbook on page 97. It was supposed to be problems numbers 13 through 28. So I'm going to try and go through every single one of those right now. There was a message I had sent out yesterday about skipping number 15, so I'm going to skip 15 as well, because, again, it is a very challenging question, and I'm not going to get us bogged down with that one. Now, for the assignment for last night, the very first question I thought was actually a fairly easy question, but it seemed to stump a lot of people on how to actually set it up. So first off, before I even get into this question, we should know the equation for slope-intercept form and point-slope form, right? So I'm going to write the point-slope form here because that's going to be the one that's most useful to us in this problem. So if I write an equation in point-slope form, all I need to know is a point that's on the line and the slope of that line, right? So the first thing you should ask yourself in this problem is, what do I need in order to write an equation? If I'm using this format, it's a point and a slope. If I'm using the other format, it's the slope and the y-intercept. Do you see any y-intercepts listed here?
No.
So it would be pretty hard to use slope-intercept form. Point-slope form, I see lots of points here, right? There's a point here, a point here, a point there. Every single line has at least one point on it, right? So point-slope form is probably going to be the easier method to go with. Next, you also have to have the slope. Well, how do you find slope? Rise or run. All right, so changing y over changing x, or you could use the equation y2 minus y1 over x2 minus x1. On here, all those things require 2 points. Only one of the 3 lines drawn on here has 2 points, and that's line N. Now, yes, they don't tell us to find the equation for line N, but that's the only one that I know the slope for at first. So use those points to find a slope. So if I draw this out, I can find my rise and my run. I went up from the point -1 up to 4, so that would be a difference of +5. I went from +1 over to +4, so that's a difference of 3. So my slope of this line here is going to be +5 over 3. Now, even though I wasn't given enough points on the other lines to find the slope, now I know the slope of this line. Should we know the slope of the other 2? Yes, because first off, M is perpendicular to N. So how does M compare to line N? What's going to be true about their slopes?
They're going to be equal.
Not equal. Opposite reciprocals. So if that was 5 over 3, this one's now -5 over 3. The other one, they gave us these right angle marks for a reason. If we have 2 lines that are perpendicular to the same line, then those lines are, I heard it somewhere over there, parallel. So if we know that this one was 5/3, this one is also 5/3. So that's the basic information we need to start this problem off. Now, we have our slope. We have points. This point here is on both the line M and Q, which are the 2 lines they want us to write equations for. So I'm going to use this point of 2, 6 and plug it into this equation. I'm going to use the slopes that we just found and plug it into this equation. So for line M, the equation can be y minus, the y1 value will be 6, equals the slope for M was -3/5. And then we have x minus, the x1 will be 2. That's it. We're done. That's the first equation. You don't have to change anything. Didn't say change it in a slope-intercept form. You can stop right there. The next one, again, we had to do line Q as well. So for Q, same equation. We even have the same point. So the only thing in this first equation that's going to change is actually the slope. That's the only thing different about line Q. So y minus 6 equals 5/3 x minus 2. And that's our equation for that one. Again, we're done. So that's all they're asking for if they ask you to write the equation of those lines. You have to know the slope, you have to know the point, because that's what's given to you, and you can use point slope form. Plug it in, you don't have to do anything else, just leave it be just like that. But you do have to know those formats. Alright, on number 14. This one. Why can you not say two vertical lines have an equal slope? Well, what is the slope of a vertical line? It's undefined. Can you say undefined is equal to undefined? No. So again, they can't have equal slopes because a vertical line is undefined. They are the same slope, right? But they're not equal. Right? So again, so the idea here is that they are undefined. So I'm going to write that down for the first part. The second part. Why can you not say that the product of the slopes of a vertical and horizontal line is -1? So normally if you have opposite reciprocals, you take them, you multiply them together, and it gives you -1. But again, a vertical line is what again for the slope? Undefined. And the reason it's undefined is because the change in x, well, x doesn't change. It stays at the same x value at every single point. So the change in x is 0. So you have a 0 on the bottom of your fraction for your slope. Again, if you have 0 on the bottom of a fraction, that's what's making it undefined. So even if I wrote out the slope in terms of 2 points, I'd have a number over 0. So even if I took that and then multiplied it by the slope of the horizontal line, which would be 0 over some number, well, the tops are going to become 0, the bottom's going to become 0. 0 divided by 0 is still undefined because you cannot divide by 0. So the idea here in both cases leads us back to it would be undefined. Vertical lines have an undefined slope, therefore we can't set them equal, and we can't find a product because they are undefined in both cases. Alright, number 16. Alright, let's see if you guys understand this a little bit. So, we have line M passes through points X and Y. Line N passes through points X and Z. If M and N have equal slopes, what can you conclude about points X, Y, and Z? Now, they are points. Points are not parallel. Can somebody give me a statement about what they think the points X, Y, and Z are? What do we know about those 3 points? Alright, so we're going back to algebra again, because this ties back into algebra. When you have parallel slopes, one of 2 things can happen. So one of 2 things can happen. Guys, it's just there from the last class, I guess. Right. Okay. Parallel. Again, if you have the same slope, you could have one of 2 things. We know parallel lines have the same slope. What other type of lines could end up having the same slope? Nope. Nope. Okay, I already said parallel. So I said from algebra, we should know that there's 2 different scenarios that have the same slope. Huh? I can't hear what you're saying. No, not right angles. Again, so again, we have the same slope. Means that you're either going to deal with lines that are parallel or lines that are the same. Now, they gave us information here saying that we have 2 lines. They have the same slope. On both of these lines, they listed X as a point that it's going to go through. Can I create more than one line that has the same slope and goes through the same point? No. Therefore, both these lines must be the same, which means that the points are all on the same line or in a row. So there's a vocab word back from chapter 1. Say it again. Yeah, collinear. Collinear. Good. So these points would be collinear. They are on the same line. So again, that one was there. It's making you think a little bit about not only what we were doing in this section, but tying it back to the previous topics. And a lot of times that's what's going to happen in this understanding section. Is to check your deeper knowledge of this idea. So, error analysis. Now, in order to have a rectangle, a couple things must be true. Rectangles, by definition, have what for angles? They're right angles. All right, so all 4 angles must be right, which means all the sides would then be not parallel. Okay, I phrased that wrong. Any pair of consecutive sides would be perpendicular because they meet at a right angle. Any set of opposite sides would be parallel. So we should have 2 sides that are perpendicular and 2 sides that are parallel. So now, looking at this equation, they gave us 4 equations in slope-intercept form. What do I need to look at in these equations to identify if we have slopes that are, lines that are parallel or perpendicular? You have to look at their, what did we do yesterday? In order to have lines that are parallel or perpendicular, we have to look at their slope. Right? So, if we look at these, here I have -3. The next one, -1/3. Those two are opposite reciprocals. On the next one, -4. +1/4. Those are also opposite reciprocals. So, I know I'm dealing with opposite reciprocals for these lines. But now the other part of what we said needs to happen for rectangles is the opposite sides have to be parallel. Am I dealing with any parallel lines here? No. None of those slopes are the same. So, could this be a rectangle? No. So, again, since none of the sides are parallel, this cannot be a rectangle. Oh, for tomorrow?
Yeah.
Thank you. Okay. Number 18 and 19. They want to know, are these parallel? So again, I need to look at the slope. They gave us the x value, so I can see the change in x. So the change here each time is 1. The change in the f of x, that's like our y. So change here each time is 15. Change here each time is also 15. So for f of x, our slope is 15 over 1. For g of x is 15 over 1. Are these two parallel? Yes. On the other one, the change here, again, 1 each time. The change here is 2. The change here is 5. Well, that means that this slope is 2 over 1. This one is 5 over 1. Are they parallel? No. Alright. Now, on this one, I would recommend finding the slope of all these lines. Some are easier than others. Now, really, J and K I can probably do just by looking. J is a vertical line. Is K a vertical line? No. So can they be parallel? No. So that one's done. M and N. So M and N, in order to be parallel, have to have the same slope. So find a point that they go through. This one goes through that point. And this point. So that's going up 4 and over 3. So now look at N. Actually, let's use that point and that point. I can clearly tell you go through. 1, 2, 3, 4, 5. 1, 2, 3. So up 5 over 3. They're close, but are they the same? No. So then P and Q. I can tell it goes through that point and this point. So this is going down 1 over 3. If I look at those 2 points, again, down 1 over 3. They have the same slope, therefore, yes, they are parallel. Alright. 23, 24, and 25. Are they perpendicular? Well, the easy ones to tell that they're perpendicular are the two that I have horizontal and vertical lines. So R and S is a yes. Because we have perpendicular lines. Because one's horizontal and one's vertical. D and E. Here's D. And E is this one. Now, they look like they could be. But again, we need to use points to make sure. So, I can clearly see that point and this point. So, I go up 1, 2, 3, 4 over 1, 2. So, 4 over 2 or just 2. Whereas on E, so you got that point and I got this point. So that's down 1 over 2. Well, if my slope here was 2, and this one's negative 1/2, are those opposite reciprocals?
Yep. Yes.
Yeah, those are opposite reciprocals. Right? If I was to flip this, that'd be 1/2, and then make it negative, negative 1/2. If I multiply these two together, I get negative 1. So those are opposite reciprocals. So that's a yes. G and H. Again, pick 2 points. I can clearly tell it goes through. There's 1. There's 2. So this is going down 3 over 2. D. No, wait, not D. What was the other one we were looking for? H. Here's G, H, H. H. Alright, this one. So, pick 2 points. There's a point. There's a point. Here I have up 2 over 3. Well, are those opposite reciprocals? Yeah. So I got yes for all 3, it looks like. Alright, moving on. Now, on this one, they gave us an equation, they gave us a point, and they wanted a line that was parallel and perpendicular to the line given and through the point. Again, if they're giving us a point, what's the easiest way to write this equation? Point slope. Yeah, point slope form. So, how do I identify what the slope is?
It's with X.
It's the one that's with X. So here, this is our slope. So for the first one, for the line that's parallel to it, that on 26, I can write y minus, y1 is negative 1, so that's going to become plus 1, equals the slope, negative 4 times x minus, x1 will be the 6, and that's the equation for the line that's parallel to it. For perpendicular, same point, just opposite reciprocal slope. So what's the opposite reciprocal of negative 4?
Positive 4.
Positive 1/4. All right. On the next one, our slope this time is 3/2. So for the line that's parallel, y minus 1 equals 3/2 x plus 1. The one that's perpendicular, again, I'm just flipping and changing the sign of my slope, -2/3. Now, you guys also had 28. For some reason, my page is missing 28 here. But
27 is different from 27. He got on my nerves when I like fifth grade. I was like, oh my gosh, wait.
I mean, I guess that's almost time to go.
When you taught him how to say that, that's not right. And then I was just like,
So again, shh, guys, listen. Hey, shh, wait. So again, this one, same exact equation. We're just changing our point for the one that's parallel. So y minus 1 equals 1/2 x plus 1. And then for the other one, change the slope. Y minus 1 equals -2 x plus 1. All right. Again, you guys already know your assignment. It's not due till Thursday.